2.6, analyzing the graph of a function, rate of change, difference quotient. Here's the definition of an even function, f of x equals f of negative x. Note that even functions have y-axis symmetry. The definition of an odd function is negative f of x equals f of negative x. So odd functions have origin symmetry. So let's take a look at f of x equals x squared and show why it is known as an even function. If we compute f of negative x, we end up with x squared, which matches the original. So f of x equals f of negative x. That makes x squared even. And then on the graph, if we fold vertically, the graph is on top of itself, and that's known as y-axis symmetry. And then let's take a look and see why f of x equals x cubed is odd. So we compute negative f of x, and we also compute f of negative x. Negative f of x is negative x cubed, and f of negative x is negative x cubed. So the definition, negative f of x equals f of negative x. That makes the function odd. And so origin symmetry is if we fold vertically, then fold horizontally, the graph ends up on top of itself. So if we have a point right here, then that mirrored point is also down here. So the negative of the y and the negative of the x. That makes x cubed odd. So let's take a look at an example of how to determine if any function is even, odd, or neither. So functions fit into one of three categories. They are even, they are odd, or they are considered neither. So this first step is to compute f of negative x. So we've got the original function of x squared plus x. Compute f of negative x, and you get x squared minus x. Step 2 is to check the definition of even. Is the original function equal to f of negative x? If it is, then you're done with the problem and the function is even. If it's not, which that's the case in this example, then move on to the next step. So since f of x is not equal to f of negative x, then the function is not even, and we move on to the next step. So the next step is to calculate negative f of x. So make sure you distribute the negative through. And for this function, negative f of x is negative x squared minus x. And then you check the definition of odd. Is negative f of x equal to f of negative x? Well, that is not a true statement. So the function is not odd. And so once you've said the function is not even and it's not odd, by default, your conclusion is that it's neither even nor odd, and you are done with the problem. So every single one of these has the same steps. Check even, check odd, make your conclusion accordingly. The next topic is increasing and decreasing. So the definition of increasing that I want us to understand is that as x gets larger, y gets larger right here. And decreasing is as x gets larger, y gets smaller. And constant is, the definition of constant is as x gets larger, y stays the same. So that's what I want us to know. And then make sure you understand that we read math from left to right. And so increasing, decreasing, and constant is written in terms of the independent variable. So as x goes from negative infinity to positive infinity, we are describing whether we are walking uphill, sliding downhill, or walking on flat ground. So if we look at this example, intuitively, we don't really have an issue determining, which section of the graph is increasing. So I think most of us are able to intuitively say, okay, this section is increasing, this section is decreasing. That's supposed to be a flat line right there, so that's constant. And then over here, this is decreasing. So that doesn't generally tend to be challenging. So what we want to understand is how to properly communicate this information. So this interval notation for increasing is the x values. So from negative infinity to -1 on the x, the function is increasing. And so the definition of these are on open intervals. So the easy way to understand or to know parentheses or brackets for increasing, decreasing, and constant is to always use parentheses. And if you take calculus, you learn about slopes of tangent lines, and that will help you understand why these definitions exist on an open interval. So increasing is negative infinity to -1. Then decreasing is from -1 to 1, union 2 to infinity. And then constant is from 1 to 2. Okay, so average rate of change, we're going to learn something called the difference quotient. So the difference quotient is the slope of the secant line from one point to another point on a function. So the author and myself prefer to use h as delta x just to have a unique symbol that doesn't also have the same symbol as the independent variable. So just note that h is delta x. So in the example, the question will say find the difference quotient, and the function is 2x plus 1. The first step is to calculate f of x plus h. So once we distribute that through, it would be 2x plus 2h plus 1. The second step is to subtract off the original function from the f of x plus h. So when we do that, we are only going to have the terms with an h attached, so equals 2h. And the last step is to calculate the difference quotient itself. So we take the result from the previous step, and that's the numerator, divide out h, and then the end result, you won't have a denominator with h because that will cancel out. So the difference quotient for a linear function is equal to the slope, but the difference quotient can give you the average rate of change between any 2 points on any function, not just a linear function. A linear function makes the example pretty clean and clear. So here's a depiction of a secant line on a parabola. So we've got, a quadratic function here. We've got this point, we got this point. So the average rate of change is delta y over delta x for that secant line. And so the slope of that secant line is the difference quotient. And so that can just give you some information about average rate of change of a nonlinear function. And then again, when you take calculus, you'll kind of take the next steps from there in terms of rates of change. So then we have library of functions. We call these parent functions. We got 6 basic functions here that we're going to learn about. So identity function, square function, root function, cubic function, absolute value function, and cubed root function. So the identity function here at the bottom of the page, domain range increasing in the intercept. Then on this page, we've got x squared, domain range increasing, decreasing, intercept, and then the minimum. And so here's the definition of maximum and minimum that I would want a college algebra student to know right now. So a maximum is a turning point that is above the points on each side of it, and a minimum is a turning point that is below the points on each side of it. So we have a turning point here. That turning point is below the immediately adjacent point, so we call that a minimum. And then here's square root, x cubed, cubed root, absolute value of x, all their domains, ranges, and important information. Then in 2.8, we learned the graph shifting properties. So here are the graph shifting properties. Just note that the shift right and shift left at first glance might appear to be backwards. But if you play with, a graph of these and you subtract a number from the input, add a number to the input, you can kind of see how that works. So we've got an up and down shift right here, left, right shift right here. f of negative x is a y-axis reflection, negative f of x is an x-axis reflection, and then f of kx means multiply x by k, and then k f of x means multiply y by k. So if we start with f of x equals the absolute value of x, so here's the absolute value function graph, and we wanted to graph negative f of x minus 3, where the x minus 3 is inside the parentheses. So first we can calculate that, so we've got the negative out front. Then instead of x as the input, it's x minus 3. So the function is negative absolute value x minus 3. Now the x minus 3 on the inside of the parentheses gives us a right shift by 3. And then the negative out front gives us an x-axis reflection. So we're going to take this graph, shift right 3, and then reflect it across the x. Then we could give the range of this function. So the range is a set of all possible outputs. So that would be from negative infinity to 0, including 0. The function is increasing from negative infinity to 3, decreasing from 3 to infinity. And we have a maximum, so which is a turning point that is above the immediate adjacent points at 3, 0. Here's another way that we can assess the graph shifting properties. So let's say that we have 2, 5, and we know that that point is on the graph. So if this is 2, 5, let me make this graph bigger. Okay, if we've got 2, 5, and it wants us to find a point on f of x minus 4, that means shift down 4. So we're going to go from 5 on the y down to 1 on the y. So the new point would be 2, 1. And then on part B, we have f of x plus 6, where the plus 6 is on the inside of the parentheses. So that's going to shift us left 6. So we start from the original point at 2, 5, shift left 6. So if we're at 2 on the x and we go left 6, we're going to be at negative 4 on the x, and we didn't change the y. There was no, these are 3 separate problems, so we don't get confused there. And then on part C, f of negative 7x means multiply the x value by negative 7. So the original x value is 2. 2 times negative 7 is negative 14. So we would know that negative 14, 5 is on the graph of f of negative 7x.